So this is the continuation of the question, which is question 30, continuation of question 13. Look, in this question, a student suggests that if the radius was increased and rotate at the same angular velocity as before, the wire supporting the plane could be vertical. So what student is saying, if we increase the radius too much, then these wires will be vertical like this. So is the student A suggestion or student 1 suggestion is right? It is incorrect. Why it is incorrect? Because if the wires are vertical, there will be no horizontal component. So if there is no horizontal, because right now what happened when these wires are making certain angle, so when the wires are making certain angle, there are two components of the tension. One is towards the center, the horizontal component, another one is a vertical component. And the horizontal component is responsible for the centripetal force. But if we increase the radius, and student A is suggesting that the wire will be vertical, like it will move in this manner. So if the wires are vertical, so there will be no horizontal component. If there is no horizontal component, there will be no component to support the circular motion or direct it towards the center. So these airplanes cannot move in a circular path. So means student A suggestion is incorrect. Then we check the suggestion for student B, that he suggested that the wire would be at an angle of a greater than 90 to the vertical. So if we are increasing the radius, the angle which these wires are making, that will be more than 90. Or we, according to student A, that if the radius is increased and it rotates at the same angular velocity, then the wire will be vertical. But that student A's suggestion is not correct. Now when we check for student B, suggestion of student B, if an angle, the radius is greater than before, then what will happen? We have the formula F is equals to M R omega square. So it means we have this formula that the centripetal force about the suggestion of student B, F is equals to mr omega square. So it shows the relation between the centripetal force and since we are keeping omega is the same and r is increasing, so if you are increasing the value of the r, because we are moving with the same speed, so omega is same, we are increasing the value of the r. So if you are increasing the value of the r, what we should do, the centripetal force should also increase. And we know according to the figure, the centripetal force in this case, when it is moving in a circular path, the weight is acting downward, there is a tension, and this tension will have the component that T cos theta and T sin theta. So T sin theta is responsible for centripetal force. So if the centripetal force is given by mr omega square, we are increasing r. So if we are increasing r, the centripetal force must increase. If the centripetal force must increase, T sin theta should also increase. So how T sin theta can be increased? By increasing a value of sin theta. And how the value of sin theta increases? By increasing the value of theta, because sin theta is directly proportional to theta. If we increase the angle, the value of the sin theta will also increase. And when the value of sin theta increase, the value of the T sin theta will also increase. So it means student B is correct and student A is incorrect, because student A is saying that if you increase the radius of the circular path, then the wire will be vertical. But if the wires are vertical, there will be no horizontal component or no component which support the circular motion. That's why student A is incorrect. About student B, as we are increasing the radius of the circular path, the angle at which it will rotate, if the speeds are kept same, the angle at which it rotates, that angle will also increase. Is it clear, this part about the suggestions of student A and B? Any doubt in this? The next question, the diagram shows an investigation of a circular motion. So we have a mass is attached. This mass will have its weight, and that weight is responsible for the tension. So the object will move in a circular path of radius r. For a particular experiment, the radius is equals to 59 centimeter. Calculate the speed of a rubber bung. The mass m is equals to 250 gram and rubber bung is 80 gram. So this m will have its weight, which is equals to mg, capital M and G. But mass should always be in kilogram when we are using in a formula. So this will give us the weight, 250 gram, which will be 0.25 kilogram, and multiplied by gravity, that's equal to weight. And that weight is equals to the centripetal force. So we can say centripetal force is equals to that weight. And centripetal force equals to mv square over r. And weight is equals to, this is capital M into G. So M is a mass, which is 80. That's the mass of the bung. So we can say it is 0.08. We divide by 1000. V square is a speed. R is a radius, 59 centimeter or 0.59. And M is a mass, which is 0.25, and G is the gravity, 9.81. So this will give us the value of the speed at which this rubber bung will rotate in a circular path, which is about 4.3 meter per second. The speed of a rubber bung is increased. Explain why M now moves to a higher position. So basically what is happening, here is the weight which is acting downward, balances with the tension acting upward, and that's the same tension acting here. If we are moving this at a higher speed, so we have the formula for centripetal force, F is equals to mv square over r. So when we are moving at a higher speed, we increase the speed, the centripetal force will also increase. So if the centripetal force is increased, what will happen to the tension here? The tension should also be as we are rotating at a higher speed and keeping a tension constant, because we did not change the weight. If we are moving at a higher speed, we have the formula F is equals to, like the centripetal force is equals to tension. And when we are moving at a higher speed, the centripetal force is given by a formula mv square over r. So we are keeping the tension is the same, tension is not changing because that weight balances with the tension. Tension cannot be changed. So to keep the tension same, the centripetal force must balance with the tension. So when we are rotating at a higher speed, so the speed is increasing. If the speed is increasing, the radius should also increase. Why the radius should increase? So the result of mv square over r will remain constant. So if the radius is increasing, so this side in a circular path, as the radius will increase, what will happen? The length which is there in the bottom will decrease because the total length of a string is same. Like from this point till here, the total length is same. But as we are moving at a higher speed, so the rubber bung shifted more toward the right hand side. So as it is shifted more toward the right hand side, what will happen? The weight will be lifted up. So to keep the tension constant, as the tension cannot be changed. Why tension cannot be changed? Because the weight is balancing with the tension. And here the tension is acting towards the center, so tension can be changed, and tension is equals to centripetal force. And centripetal force is equals to mv square over r. So if you are moving at a higher speed, the radius should also increase so that the result will be balanced, or the tension should not change. That's why the weight is lifted slightly upward. As the length of a string or a string shifted towards the rubber band, that's why this weight is lifted upward. Is it a clear discussion that why the weight is lifted upward when we increase the speed of rotation? The speed of a rubber band is increased. Explain why m now moved to higher position that we did. In order to calculate the speed of the rubber band, the time for one rotation must be determined. Student A suggests number of rotation in a fixed time should be counted, and student B suggests measuring a time for fixed number of rotation. Explain which method will produce more accurate result for the time. So student A, what he suggests number of rotation should be fixed in a fixed time. Like time should be fixed, like how many rotations are there, example in 10 seconds. But maybe in 10 seconds, it might have like not complete rotation, it might have 3.5 rotation, but it's hard to determine in 10 seconds when it is rotating, it may not cover. Student A suggests like we should make a time fix and count the number of rotation in a fixed time. So maybe when it is rotating in 10 seconds, it rotated 1, 2, and then it is here. So it may not cover the full rotation or complete the rotation. So student A's suggestion is not correct. Why? Because it's difficult to identify the rotation in between. But student B suggests measuring a time for fixed number of rotation. Like measure a time for 10 rotation, 20 rotation, that will be more accurate. So why student A is not accurate? Because when with a fixed time, there may not be a whole complete rotation, but if it is possible to measure, like if we know the fixed rotation, so we can measure a time, and time can be decimal like 3.1 second, 5.1 second, so it will be easy to determine. That's why student B is accurate or correct, and student B is not accurate. Because student A is saying that keep the time as 10 second or 20 second and measure the vibrations. And student B is saying keep the vibration same and measure the time. So we keep the vibration like 10 second and we start the timer. And once it complete the vibration, we stop the timer. And to get the time period, it will be the total time divided by number of vibrations. In question 15, the photograph shows a drum inside a washing machine during a hollow metal. The drum is a hollow metal cylinder with a series of holes are there. During the spin cycle, the drum rotates about 1400 revolution per minute. Show that the speed of point X on rotating drum is about 35. The diameter of the drum is 0.48. So we have the total diameter of the drum. We want to find the speed. We need V. So we have the formula V is equals to R omega, and omega is equals to theta divided by T. So, or we can work out omega first. how to work out omega from the values that 1400 revolutions are there, multiplied by 2 pi and divided by time in minutes, so this will be 60. This will give us the value of omega, and the radius will be half of the diameter. So that is equals to 0.240 multiplied by 2 pi into 1400 divided by 60. And what we need, show that the speed of, so V is equals to R omega, so we work out the speed of this drum. A shirt button remain at a single point in a drum as a drum spin. Calculate the centripetal force. So and the mass of a shirt button is 1.4. So centripetal force is equals to mv square over r. We have the mass in gram. We have to convert into kilogram. We have the speed in the previous part in the radius. So we substitute and get the value for r. Explain how a drum. How the drum spinning separate the water from the wet cloth. So, like example, if there's a wet cloth, the water will particles will go out and the wet cloth will be dry. So, because as a result, because what happened, this drum is having holes, and these are example the water droplets in the cloth. So these water particles can go out from the holes, so they don't have any centripetal force. But for a cloth, what happened? As a cloth is in contact with a drum, so there is a normal contact force from the drum, and normal contact force is directed towards the center. That will keep this. The normal contact force, which is R, is directed towards the center. So there's a centripetal force on the cloth. That's why the cloth will continue to rotate. But the water drops or droplets does not have any centripetal force. So they will move out from the circular path. And that's how the water droplets are separated from the cloth. So water is not having any resultant centripetal force, but the cloth is experiencing a centripetal force as a normal contact force from the drum. And water continue its motion, or it will go out from the circular path, and the direction in which, because when object is moving in a circular path, it will leave tangential to the circular path. So that's how the water is separated from the wet cloths. So this was exercise related to circular motion.